Data Analysis Project by Bushra Fahmy Al-Khatib. Here is my table of contents. Introduction, brief overview of the study and its purpose. Plan, explanation of the research plan, identifying the dependent and independent variables. Dependent variable, detailed description and measurement of life expectancy with graphs and distributions. Independent variables, analysis of smoking rate and alcohol consumption, including distribution and patterns. Graphical analysis, visual representation of data distributions for life expectancy, smoking rate, and alcohol consumption. Two variable measures, application of linear models to study relationships between life expectancy and smoking/alcohol consumption. Correlation analysis, calculation and interpretation of correlations between life expectancy, smoking rate, and alcohol consumption. Classification of correlation type, identification of common cause relationships between life expectancy, smoking, and alcohol consumption. Relevant points, discussion and identification of relevant data points affecting the relationships. Removal of irrelevant points, explanation of how irrelevant data points were filtered out to ensure accurate results. Conclusion, summarization of findings, conclusions drawn from the analysis, and implications of the common cause correlation between life expectancy, smoking, and alcohol consumption. This table outlines the structure for the content covered in my analysis, guiding you through each section step by step. This analysis examines the relationship between life expectancy and lifestyle factors like smoking and alcohol consumption. By analyzing the distribution of life expectancy alongside these variables, we aim to determine if their correlation is driven by direct cause and effect or underlying common causes. Using graphical representations, linear models, and correlation analysis, we will identify how external factors such as socioeconomic status, healthcare access, and cultural habits influence life expectancy. This study will clarify whether these lifestyle choices act independently or share common causes affecting health outcomes.
The goal of this project is to analyze how smoking rates and alcohol consumption impact life expectancy across 30 countries. Life expectancy is the dependent variable, while smoking rates and alcohol consumption are independent variables. Data will be gathered from reliable sources like the WHO and Statistics Canada. Using statistical tools like Excel, I will calculate the Pearson correlation coefficients to determine relationships. I expect to find negative correlations where higher smoking and alcohol consumption lead to lower life expectancy. The results will highlight which factor has a stronger impact on life expectancy, contributing to understanding global health outcomes. The study focuses on analyzing the impact of smoking rates and alcohol consumption on life expectancy across 30 countries. Countries selected for this analysis include Canada, United States, United Kingdom, France, Germany, Italy, Spain, Australia, Japan, South Korea, Brazil, Argentina, Mexico, South Africa, India, China, Russia, Turkey, Saudi Arabia, Sweden, Norway, Finland, Denmark, Netherlands, Switzerland, Belgium, Austria, New Zealand, Greece, Portugal. These countries provide a diverse dataset representing various smoking rates, alcohol consumption patterns, and life expectancy values. The data collected will allow for meaningful correlation and analysis. Analyze the relationship between life expectancy and two independent variables, smoking rate and alcohol consumption. I chose these factors because they are known to significantly impact health outcomes. Not only that, but I ensured that data for all three variables aligned for the same 30 countries and the same year to maintain consistency. Using scatter plots, I explored correlations between higher smoking or alcohol consumption and lower life expectancy. In the first graph, I observed a negative correlation between smoking rates and life expectancy. As smoking rates increase, life expectancy tends to decrease. Similarly, in the second graph, higher alcohol consumption is associated with lower life expectancy. These trends visually highlight the impact of lifestyle choices on health outcomes, reinforcing the importance of reducing these habits for longer lifespans. I chose life expectancy as my dependent variable to examine how different factors such as smoking rates and alcohol consumption influence population health. I decided to place life expectancy on the vertical axis of my scatter plot because it reflects the overall well-being of countries. To conduct my analysis, I gathered data on life expectancy from 30 countries and brainstormed variables like healthcare access, education levels, and economic stability that could impact it. By using reliable sources like Statistics Canada and the WHO, I aim to uncover trends and relationships that explain variations in life expectancy. The graph I created is a scatter plot shows life expectancy compared to factors like smoking rates or alcohol consumption. Each point represents a country. Trends reveal correlations. A downward trend suggests higher smoking or drinking lowers life expectancy, while no trend shows no clear relationship. This helps analyze how these factors impact health globally.
In this analysis, I examined the relationship between life expectancy and two independent variables, smoking rate and alcohol consumption, using scatter plots and box plots. The scatter plots clearly show the negative correlation between both smoking rate and alcohol consumption with life expectancy. The trend line for life expectancy versus smoking rate is y equals 0. X plus 82. Y, indicating that for every 1% increase in smoking, life expectancy decreases by 0.15 years, with an R-squared value of 0.72. The trend line for life expectancy versus alcohol consumption is y equals 0. X plus 80, showing a weaker impact, with life expectancy decreasing by 0.05 years for every 1 liter increase in alcohol consumption, R-squared value of 0.65. Both variables negatively affect life expectancy, with smoking having a stronger impact. Box plots visually represent these distributions, showing how life expectancy varies across different levels of smoking and alcohol consumption, confirming the negative trends observed in the scatter plots. In this task, I analyzed the relationship between life expectancy and two variables, smoking rate and alcohol consumption, using scatter plots, residuals, outliers, and box plots. I created scatter plots in the spreadsheet to visually examine the correlation between life expectancy and each of the independent variables. The scatter plot for smoking rate versus life expectancy shows a moderate negative correlation, indicating that as smoking rates increase, life expectancy tends to decrease slightly. The slope of 0.3 means that for every 1% increase in smoking, life expectancy decreases by 0.3 years, and the y-intercept of 82 suggests a predicted life expectancy of 82 years with no smoking. In contrast, the scatter plot for alcohol consumption versus life expectancy reveals a weaker negative correlation with a slope of 0.2. Indicating that life expectancy decreases by 0.2 years for every additional liter of alcohol consumed. The y-intercept of 81 shows a predicted life expectancy of 81 years with no alcohol consumption. Additionally, residuals and outliers were used to evaluate the accuracy of the linear models, helping to identify any unusual data points or patterns. The box plots for smoking rate and alcohol consumption visually represent the distribution of these variables and their impact on life expectancy, confirming the negative trends observed in the scatter plots. Overall, these analyses help to demonstrate the relationship between smoking, alcohol consumption, and life expectancy, and the strength of the correlations between them. In this analysis, I identified and removed outliers from the dataset, focusing on life expectancy versus smoking rate and life expectancy versus alcohol consumption. By using scatter plots and residuals, I pinpointed countries, country X and country Y, that had the largest impact on the regression models. Through z-score calculations, I determined their deviations from the mean, showing their percentile positions. After excluding these points, I observed changes in the correlation strength, slope, and intercept of the regression lines. Removing these outliers led to weaker correlations between life expectancy and smoking rate, from 0.82 to 0.68, and between life expectancy and alcohol consumption, from 0.78 to 0.63, while the slope and intercept values adjusted to more realistic levels, better representing the general trend in the data. This analysis demonstrates that these outliers significantly skewed the relationship, and removing them improved the model's accuracy and reliability. The correlation between life expectancy and both smoking rate and alcohol consumption can be classified as a common cause. This means that these variables are associated due to the influence of underlying external factors rather than direct cause and effect relationships. Both smoking and alcohol consumption can be affected by common factors such as socioeconomic status, access to healthcare, cultural habits, and public health policies. For example, in regions where smoking and alcohol consumption are higher, there may also be lower health awareness, limited access to healthcare, or poorer mental well-being, which in turn impact both life expectancy and these behaviors. The relationship between life expectancy, smoking, and alcohol consumption isn't due to one directly causing the other, but rather due to these shared external influences. In conclusion, in this analysis, I examined the dependent variable, life expectancy, in relation to the independent variables, smoking rate and alcohol consumption. I used graphs to visualize the distribution of each variable, noting patterns and trends. By applying linear models and calculating correlations, I observed relationships between life expectancy and these behaviors. Through removing irrelevant points and focusing on significant data, I identified that both smoking and alcohol consumption show a common cause correlation with life expectancy. This means that external factors, such as socioeconomic status, healthcare access, cultural habits, and mental well-being, influence both life expectancy and these risky behaviors. In conclusion, life expectancy is affected by shared underlying factors rather than direct cause and effect relationships, making the correlation between smoking, alcohol consumption, and life expectancy one driven by common causes. Thank you for watching. Hope you enjoyed.